Welcome back to another episode of West Explains Best. Today we're going to be doing a Kuta software worksheet tutorial on volume of prisms and cylinders. Let's go ahead and get started. Here we have number one. It looks like a soup can. What do we know about this soup can? Well, it's got two bases. It's got a circle on top and it's got a circle on the bottom. I know it looks like an oval. That's because it's drawn based on perspective. Now, what is this thing? This is called a cylinder. This cylinder is essentially a circle that you take and you stretch it out so that it contains more than one dimension. It has multiple dimensions. It has 3 dimensions to be precise. And now it just doesn't occupy 2D space, it occupies 3D space. Now, how do we find the volume of this? Or what is volume in the first place? So volume is the amount of space a 3D object takes up, just as area is the amount of space a 2D object takes up. So how do we go from a 2D object, which is a circle, into a 3D object? The first thing we need to understand is we need to understand the area formula for our base. So finding the area of the base is super important. So for volume, we need to know the area of the base. Very important to find the area of the base. Now, what is our base here? Well, our base is pi r squared. That is the area of a circle, so that is our base. Now, if we just started out with a circle, that would be the amount of space it would take up in 2 dimensions. But imagine we are just grabbing this 2D circle and we are stretching it into 3 dimensions. We're stretching it into a 3rd dimension, so it takes up volume. It takes up space in 3 dimensions now. Well, how would we figure that out? Well, if we were to just do 2 of these thin slices, okay, we would just take the area and we would double it, and then we could just keep multiplying it by the amount of tiny little slices that we add. Well, what is that distance? What is this whole distance called? Or what is it known as? What is that distance right there of our cylinder? That is called the height. So our volume is going to be the area of our base times the height. And that is true for any prism. So any prism, you take the area of the base and you multiply the height, and that's what you get. Well, we have some information now. For number 1, we know that our radius equals 8. We know that our height equals 7. So that's all we need to go. So we're going to set this up. Volume equals our area of the base, that's pi r squared, and then times our height. Let's input our values. So we have pi, and then we're going to put, instead of r, we're going to put 8, and we're going to square it. And then we're going to multiply it by a height. Our height, and that's 7. So now we have, round your answer to the nearest tenth. I just wanted to see if we're leaving in terms of pi. I'll do both. So we have 8 squared. I'm going to get my calculator. Not that I need 8 squared, but we're going to multiply it by 7 soon. Times 7, and we have 448. So we have 448 pi. Now I'm going to go ahead and multiply that by pi so you can see what it is as decimal. And I get, or 1,407 round to the nearest tenth as needed, 0.4 kilometers, but kilometers is a measure of distance. Kilometers squares is a measure of area. Kilometers cubed is a measure of volume, and that is our answer. That is one gigantic cylinder, is all I'm saying. Let's do a tough example next. All of these are going to apply by the same formula, by the way. So if you're wondering, what do I do for the cube? Well, you're going to apply the same formula. You're going to take the area of the base times the height. Now, for any rectangular prism, because a rectangular prism, technically you can consider any of the base, you could call any of the base. So you could call, let me make this a little bit smaller. You could call this side the base, okay, and call that a base, or in this a base. You could call the top one a base because it's a rectangle, and the bottom one a base. That's fine too. You could call the back and front one a base. That would work too. So it doesn't really matter for rectangular prisms, and what you're ending up doing for rectangular prisms is you're going to do the length times the width times the height. So you just multiply the 3 dimensions for a rectangular prism. So those ones are pretty easy. I don't want to go too much into that one. I just covered cylinders. So let's cover this one. This is a pentagonal prism. And again, the volume is going to be equal to the area of the base times the height. Well, let's start with the area of the base. Area of the base, we have a pentagon. It's a regular pentagon, so we're going to use the formula of 1/2 the perimeter times the apothem. The apothem being this guy right here. So we already have one of the distances, or yeah, measurements. The apothem equals 5.5, so we're going to say 5.5. The perimeter. Now this is where it's going to get a little tricky. I see. It gives us a value of 8, and it tells us that all these distances are equal. So we know our perimeter is going to be equal to 8 times 5, or 40. 8 plus 8 plus 8 plus 8 plus 8, all the sides equals 40. You're going to multiply that by 1/2, and that's going to be equal to our area of the base. So essentially what we're going to be doing is 40 times 1/2, that's 20, times 5.5, that gives us the good old-fashioned 110. So that is the area of our base. Now the height, we're already given 2. We already know our height. Our height is, let me use orange, our height is 8. That's how high the prism is. Think of the height as the distance between bases. Okay, so anytime you're thinking about height, you're thinking about the distance between bases. And we're talking about area, we're talking about the area of the base, and we're talking about perimeter, we're talking about perimeter of the base also, okay? So now we have our area of the base, that's 110. We have our height, that's 8, and now we just need to multiply. So in many regards, this is much easier than surface area. A lot of people like volume a lot better. And we get 880 inches, don't forget the units, cubed, okay? Because we're talking about 3 dimensions, so the units are also cubed. And I think this is a great enough start. Just keep in mind, with the triangle, you need to use area of the triangle, 1/2 the base times the height. I'm trying to think if there's any shapes. For area of a trapezoid, you're going to use 1/2 base 1 plus base 2 times the height. And then that's the area of the base. Volume equals the area of the base times the height of the prism. Keep that in mind. And then that's it. I mean, all these other ones you should be able to do. So I hope you guys found this helpful, and I look forward to seeing you next time on Wes Explains Best. Take care.